In this video, we will evaluate a triple integral by converting it into cylindrical coordinates. So in this integral, we're just integrating the function x squared, and the region given to us is inside of the cylinder, above the xy plane, and below a certain cone. So it looks something like this. Here's the cone. So it's like this region. Underneath the cone, but inside the cylinder. Okay, so let's convert this to cylindrical coordinates. Maybe first let's note what all of these equations look like. So in cylindrical coordinates, the equation for the cylinder is just r equals 1. Z equals 0 is the same, because z means the same thing in cylindrical coordinates that it does in usual xyz coordinates. And the cone, we can rewrite as z equals 2r. So, here's our original integral, and if we convert it, x squared, remember x, the conversion is the same as in polar coordinates, so x is r cosine theta, but it's squared, so r squared cosine squared theta. And dv becomes r dz dr d theta. So we get an extra r, so actually this will be r cubed. And now we have to write the bounds. If we try to do it in the order that I wrote, z comes first. So the first integral, the bounds need to represent the top and the bottom. The bottom is just z equals 0, and the top is the cone, so that's z equals 2r. And then the outer two integrals need to describe the shadow or the projection of the region down in the z direction, meaning onto the xy plane. So in this case, that's just the disk of radius 1. As you can see in the picture, it's just the bottom of the region is that filled in circle of radius 1. So that's r goes from 0 to 1, and theta goes from 0 to 2 pi. And now we just do the triple integral. So there's no z in the integrand function, so the first integral just multiplies everything by 2r. So we get r to the 4th cosine squared theta. Now we integrate r. So we just integrate r to the 4th. We get r to the 5th over 5, so we'll put the 1/5 outside. And r to the 5th from 0 to 1 is just 1. It's 1 to the 5th minus 0 to the 5th. And remember that the way to integrate cosine squared is to use the trig identity. That cosine squared is equal to 1/2, so I'll multiply by 1/2, cancel that 2. 1/2 times 1 plus cosine of 2 theta. So the first term, the integral of 1 from 0 to 2 pi is just 2 pi. And the antiderivative of cosine 2 theta is 1/2 sine of 2 theta, which we have to evaluate from 0 to 2 pi. But that's just 0. Right? If you plug in 2 pi and 0, sine of 2 theta is 0 in both cases. You just get 0 minus 0. So our final answer is just 2/5 pi.